the curious 819-day calendar of the Maya. In 1943, an archaeologist discovered that the Mayans used a mysterious 890-day calendar. For decades after, the point of this cycle was not understood. But then, in 2023, it was discovered that this cycle matched up beautifully with all the visible planets. That is, with Mercury, Venus, Mars, Jupiter and Saturn. At the end of this lecture, you'll fully understand how this all works, and also how it was written down in the beautiful Mayan script. So, we have a lot to get to. Let's start. Hey, good to see you. This is Stephan, author of In Search of the Sublime. On this World History channel, we'll trace humanity's relentless pursuit of scientific truth, moral excellence and enlightenment. We'll meet anyone from Mesopotamian astronomers and Indian yogis to Greek philosophers and Enlightenment scientists. And you'll meet them firsthand using primary sources, giving you valuable insights that transcend the surface level understanding you get on other channels. Go check it out for yourself. Let's start. In 1943, Sir J. Eric S. Thompson, one of the most important scholars of the Maya, wrote an article about the strange pattern he found in Maya inscriptions. In each of these inscriptions, the date of an important historical event was given in the so-called Mayan long count calendar. And this calendar gives the number of days since a specific date in the far past, namely the 11th of August, 3114 BC. And close to this Mayan long count date, he also always found a so-called distance number. And then he did the following. If we subtract that distance number from that long count date, we arrive at yet a second date. And for clarity, every time I refer to this second date, I use a red font, as you can see here. And now comes the clue. If we look at all those second dates that we found by subtracting the distance number from that long count date, we find that all those second dates are a multiple of 890 days apart. So for instance, those second dates might be 1 times 290 days apart, or 2 times 890 days apart, or 3 times 890 days apart, etc. A whole multiple of 890 days apart. Take the following long count date on Stela 1 at Palenque, an important Mayan site. It reads 9, 12, 6, 5, 8. And I'll tell you now how to read this calendar date. The first number, the 9, corresponds to a number of baktuns, which is a period of 144,000 days. So we have 9 times 144,000. The second number corresponds to a number of katuns of 7,200 days. The third number refers to tuns, which are 360 days. The fourth number refers to wynals of 20 days. And the last number, the sixth number, refers to a number of kins, which are single days. And if we add all those days up, we get to 1,384,668 days. And if we add those dates to that starting date, somewhere before 3000 BC, we get to the 7th century AD. So this refers to an important event, likely to do with a king, that happened in the 7th century AD. After this date, we also find that distance number, and the distance number is 110,1, and in a similar way that corresponds to 561 days. And if we then subtract that number, 561, from that long count date, 1,384,668, then we find the second date at 1,384,107 days. And this is how Thompson found those second dates. Now here we have 4 more examples that you can go through if you want to, and in red you see those second dates. Doing this, we are left with the following numbers here described in red at the top. And now comes the trick. Thompson found that all these dates are a multiple of 819 apart from one another. For instance, if we take the first number, 1,384,107, and we add 14 times 819, then we get to the second date, 1,395,573. And we can do this in all cases. For instance, if you take the second and the third number, they're 19 times 819 days removed. And if you take the third and the fourth number, they are 4 times 890 days removed. And this seems too coincidental to just be a chance occurrence. So, in conclusion, all these dates are located on 890-day intervals. And today about 20 of these inscriptions have been found. The earliest dating from the late classical period, that is between 600 and 900 AD. And the majority of these inscriptions come from Palenque and Yaxchilan, and there are also a few from some other sites, such as Copan. And there is something more. There is also another clue that we are right to subtract these distance numbers from that long count date. For there are also 2 dates mentioned on these inscriptions from the so-called Maya calendar round, which is yet another type of calendar that the Mayans have. And this calendar has a length of 18,980 days, which is made, by the way, with combining a 365-day year with another strange 260-day calendar that still isn't fully understood. And if you combine these 2 calendars, you get a cycle of 18,980 days. Now, what about those 2 dates in that calendar round notation? Well, if we assume the first of these dates to correspond with that original long count date, then the second date matches perfectly on this calendar with that second long count date that we found by subtracting the distance number from that first date. So those 2 long count dates correspond with those 2 calendar round dates, which reassures us once more that we're doing the right thing by subtracting that distance number. Now, let's look how this was all written down. Let's look at the glyphs for a moment. A few years after Thomson, it was discovered that these dates were often accompanied by a so-called direction glyph, saying either east, north, west, or south, and also an associated color glyph. East is always associated with red, north with white, west with black, and south with yellow. And then we also often see a glyph for a god called Kawil. That must have had something to do with this cycle according to Maya mythology. Let's for instance take a close look at lintel 29 and 30 from Yaxchilan. On lintel 29 we read the date of birth of Lord Yaksung Balam IV, also called Bird Jaguar IV, at the long count date 9, 13, 17, 12, 10. And we see these numbers from B1 till B3. And it is quite easy to see these numbers written down. A line corresponds to 5 and the dots correspond to 1. So here we see 5 plus 4 is 9. Here we see 5 plus 5 plus 3 is 13. Here 5 plus 5 plus 5 plus 2 is 17, and so on. And that's how you read that long count date. 9, 13, 17, 12, 10. And this, by the way, corresponds to an exact date, the 27th of August, 709 AD. Now we move to the associated lintel 30. And here we find that distance number, in this case 1711. The 17 we find at E1. We see 3 stripes and 2 dots, that's 17. The 1 we see on the top right of E1, and another one we see at the left of F1. And then we also have those glyphs for the color and the direction. In this case we see east, which is written at F3, and red, which is written at E4. And then at E5 we have that mysterious god, Kawil. Then we also have those 2 dates of that other calendar, the so-called calendar round. In this case we read 8 Ok, 13 Yax. And if you want to know more about this notation, then see my lecture on the Maya calendar. You can find them at A4 and also at G1. And this is the calendar round date that is associated with the first long count date. And then we have 1 Ben, 1 Chen, which is written at E2 and F2. And this date is correctly related to that second long count date. Now that you know the general pattern that we see in almost all inscriptions, they work exactly like this, we'll now study an exception, a strange case, which was long not understood. At the Temple of the Sun at Palenque, there is an inscription as we expected with a long count date, 1-18-536, and also an associated calendar round date, 13 Kimi, 19 K, and also a distance number 1 to 11 that corresponds to 411 days. And there is also a second calendar round date, in this case 1 Ik, 10 Tek. So all the dates as you would expect them by now, 2 long count dates and 2 associated calendar round dates. But in this case there is something curious, because the calendar round dates at this time do not match up. We do not get to the date 1 Ik 10 Tek by subtracting that distance number as we did on all the other inscriptions. And on top of this, the day that you find by subtracting it is not on an 890-day station. And because this is also out of whack, it was long assumed that it was an error. Although if you do the actual calculations, it is an unlikely large error. So it is more likely that there is another explanation. And this explanation was finally found by Lounsbury, who found that we can get back to that date 1 Ik 10 Tek and also get back to an 890 station if we go back 83,004 days back in time instead of just the 411 days as we would expect with the distance number. Now, this is quite a calculation, given that we're dealing with 3 different calendars now, so I wrote a quick JavaScript model to verify whether that 83,004 days was correct. I let that program run through the calendar round, starting at the date 1 Ik 10 Tek, and then it went on to look for all cases of 13 Kimi 19 K, which was the second calendar date mentioned on that inscription. And then I also checked if the intervals that I obtained in this way are multiples of that 890 days removed from the second date inscriptions on all the other steles. The first 7 encounters of that 13 Kimi 19 K were not 819 stations, but the 8th one was, and it was indeed 83,004 days removed from that original long count date. And now comes the clue. If we subtract that distance number of 411 days from that number 83,004 days, we end up at 82,593 days. And Lounsbury then showed that this is an exact multiple of the 399-day synodic period of Jupiter. That is, how long it takes Jupiter to orbit around us and return to the same spot relative to the Sun. For if we take that number 399 and we multiply it by 207, we exactly get to that 82,593 days. And although this might just be a coincidence, it was a first clue that those inscriptions could have something to do with the planets, in this case Jupiter. And by the way, there was also some other information to confirm this. That same date, 1 Ik 10 Tek, was also found on another inscription on the so-called Temple of Inscriptions medallion series. And in this case it was on the correct 819-day count station that preceded a specific rite when Lord Khan Balan II celebrated what seems to be a triple conjunction of Mars, Jupiter and Saturn, when all these 3 planets were close to each other, which happened on that exact date. So again, that 890-day calendar seemed to be associated with the planets. And there's more. Other dates mentioned related to that same Lord Khan Balan II were also related to the stationary points of the planet Jupiter. All the planets make so-called retrograde motions, where they sometimes seem to stop in their motion, return, stop again, and then continue in their orbit. And these endpoints are called the stationary points. And this king seemed to have timed important days in his life with those stationary points of Jupiter. And also again to that period of 399 days. Everything he did seemed to have something to do with Jupiter. And there is even more. If you multiply 7 by 117, we also end up at 819. And in the Dresden Codex, one of the most important astronomy books from the Mayas, there is an important table that is divided into 20 rows of 117 days. Very curious to have a row of 117 days. And it is now believed, although not definitively proven, but quite likely, that it has something to do with the synodic period of Mercury, which is actually 116 days on average. But I have to say the period of Mercury is not fixed. It's sometimes a few days longer, sometimes a few days shorter. So 117 is still within the range. And this might at least explain why they have that 170-day calendar. And by the way, that same table might also count the period of Venus, which they count as 585 days instead of the usual 584 days. Now, why might they have done this? Why didn't they take the exact numbers which they knew, as we know from other texts? Well, the total length of this table in the Dresden Codex is 20 times 117, or 2,340 days, the total length of that calendar. And this is equal to 9 times 260, which is a whole number of their important Tzolk'in calendar of 260 days, which we shortly discussed before earlier. And this we see a lot with the Mayans. Most of what they do is a multiple of the 260 days. So that 2,360-day calendar beautifully matched up with that Tzolk'in calendar, but also with the adjusted orbits of Venus and Mercury. For 117 times 20 is that number 2,340 days, and 585, the period of Venus, times 4 is also 2,340. So this one calendar seems to fit a whole number of Tzolk'ins, a whole number of Venus periods, and a whole number of Mercury periods. And now we can finally get to the trick to explain that 819 calendar fully. And given the quite complex lecture so far, you might expect a very complex answer, but that is not the case. It's actually quite clean. In 2023, John Linden and Victoria Bricker, in their paper called The Maya 890-Day Count and Planetary Astronomy, they found the following. They found that a whole multiple of the period of every visible planet fits neatly in a multiple of that 890 days. Let me show you what I mean by this. If we take the period of Mercury, that 170 days, and we multiply it by 7, we get 1 times 819. If we take the period of Venus, 585 times 7, we get 5 times 819. If we take the period of Saturn, 378, and we multiply it by 13, we get 6 times 819. If we take the period of Jupiter, 399 days, we multiply it by 39, we get 19 times 819. And for Mars of 780 days times 21, we get 20 times 819 days. So in this way, the periods of the planets all match up to that 819-day calendar, that repeated interval of 819 days. Very beautiful indeed. And notice, by the way, here that the longest interval of 819 days corresponds to Mars. We need 20 intervals of 890 days to have all the cycles of the planets repeat. So, to repeat, we need 20 cycles of 890 days to match all the planets to this cycle. And 20 times 819 is 16,380 days. That seems to be the full cycle to get all the planets to return to their exact positions. And by the way, this interval 16,380 has been found on various inscriptions at Palenque, suggesting that this number was indeed very important to the Mayans. And there is even more. As you might have expected by now, that 16,380 days also fits beautifully with that 260-day Tzolk'in calendar. For 260 times 63 is exactly 16,380 days. So it doesn't just match with all the planets, also with that Tzolk'in calendar. And there's even more. The Tzolk'in calendar works as follows. It moves through numbers 1 to 13 as the days progress, and at the same time it moves through 20 day names. Those names we've seen before, it can be Ek or Tsek or Ben or Chen, etc. And those 13 numbers and those 20 day names combine to 20 times 13 to 260 combinations. And that's how we get to that 260-day Tzolk'in calendar. But because 819 is also a multiple of 13, namely 13 times 62, if we jump from one 819 station to the next, because it is a multiple of 13, we always get to the same number on the Tzolk'in calendar. So if we start on a Tzolk'in calendar of 1, and we move one step ahead in that 819-day calendar, we again get to 1. Because after 13 days, we always get back to the same number. So we always get back to 1. And in the descriptions that we saw in the beginning of the video, we indeed read the Tzolk'in dates 1 Manik, 1 Ben, 1 Ix, 1 Ok, and another 1 Ok. And this has some important implications. Because we only get the Tzolk'in dates starting with 1 in that 819-day calendar, those 216 combinations decrease to just those 20 day names. Because all the numbers are always 1, we only have those 20 day names left as variations. And beautifully, it is just 20 day names that we need to describe that whole cycle of that 890 days, because it took 20 steps to get to the cycle of Mars, the largest cycle in that calendar. So those 20 day names can beautifully describe where we are in that 819-day cycle of all the planets. And here we see this beautifully described. In the first column, we see all the Tzolk'in dates. 1 Imix, 1 Aja, etc. There are 20 different day names, and the number, as we've discussed, is always 1. And in the second column, we see where we are at in that 890-day cycle. We have 1 times 819, 2 times 819, etc. In the third column, I've calculated the exact number of dates, going all the way at the bottom to that 16,380 days. And then in the last column, we see which planets have their periods matched up with that 890-day calendar. In all cases, we see that Mercury matches up, because 7 times 117 was 890 days. So Mercury makes 7 orbits every 890 days. At the 5th interval, we get to the period of Venus. The 6th, we get to the period of Saturn. And all the way at the 19th, we get to Jupiter. And at the 20th, we finally get to Mars. And there we have it. The solution to that mysterious 890-day cycle. Thank you so much for watching, and if you want to know more about the Mayans or any other topic for world history, then please read my book In Search of the Sublime. You can read it completely for free on worldhistorybook.com, or you can buy a copy on Amazon. Thank you so much for watching. Bye bye.